Good day. My name is Dina Botha, and today we're talking about sampling. And not just any sampling, real-time, automated, metallurgical accounting sampling. So that is a bit of a mouthful. So here at Multotec, we just call it RAMA. And although I am sure you could taste the love, I wouldn't necessarily recommend it. Multotec has on numerous previous occasions talked about sampling, theory of sampling, sampling implementation. That is not why I'm here today. Today, we're talking about innovation. But before I can tell you about the RAMA system and where it can be introduced, we need to cover one or two basics of sampling. So the first thing we always need to ask when we want to install a sampler is, why are we sampling? What are we going to do with the results of this sample? Now, sampling are mainly used for two purposes: process control or metallurgical accounting or process evaluation purposes. Process control samplers are usually used when you want to have quick results, when you need to make instantaneous changes on your process. They can be used to obtain mineral balances over your process plant. They can be used to identify process problems and find subsequent solutions. And they can be used to improve your overall process efficiency. On the other hand, we have process evaluation samplers. These samplers usually take a batch sample over a shift period and can be used for metallurgical accounting purposes. These analytical results can be used for process modeling. They are reliable and can be used for decision making. They can be used for process auditing purposes. And ultimately, they are used to ensure that your final product is within the correct quality or grade as the client specified. And they can be used for contractual payment purposes. Now, these are the two methods that we usually use to approach sampling. But are these samples representative? What is a representative sample? A representative sample, as stated by POG, is a correct, accurate sample that is sufficiently reproducible. Imagine you are on Facebook or you are driving down the road and you see an advertisement and it states some statistics of a poll that was taken. And you think to yourself, something doesn't seem right. And that might be because you don't know how that sample was taken. Who did they ask? Is that opinion stated actually the opinion of everyone? When we take this back to slurry, the theory of sampling states that in order for a sample to be collected to be representative, each and every particle in your process stream needs to be given equal opportunity to be sampled. Maybe you are wondering why that poll doesn't make sense. It's because you weren't asked. You weren't given the opportunity to state your opinion. If we look at sampling in a horizontal process line, you will have your slurry flowing in this pipeline from left to right or into the screen in this line. As with horizontal lines, you will have segregation occurring in your process stream. Here at the bottom, we have our more dense, larger particles. In the middle is our less dense, intermediate-sized particles. And your finer, even less dense particles will stay in suspension in your medium. If we look at this process line specifically, we have 4 light particles, 10 intermediate particles, and 14 heavy particles. Taking that down to fractions, we have, if we look at specifically at the larger red particles, they are 50% of our sample. Now, when we take a sample of this material, we want those exact results to be represented on our data. An example of a sampler that is used a lot of the times in a horizontal line is a shark fin sampler. So, a shark fin sampler has a static cutter that sits in the center of your process line. If we take a look at how this cutter will sample the material, you'll see we are giving every particle, more or less, from the top to the bottom, a good chance of being represented. But what about the sides? What about left and right? Even though we are not sampling through the whole process stream, we are still getting a relatively good mixture of material and particles. But if you look specifically at the fractions, our larger red particles, that was previously 50%, is now only stated as 44%. That is a whole big difference. Another sampler commonly used is a poppet sampler. Now, a poppet sampler has a tube that extends into your process line. It fills up a sample chamber and extracts the material and discharges it. Depending on your process line size and the orientation within which you install the sampler, you might not protrude through the whole process line, and you might represent some particles more than what they actually are, and you will underrepresent other particles. Some of them you might even totally miss. So we have learned a thing or two. Maybe some samplers are better installed on vertical process lines. Now, if we look, for example, at this vertical process line, we have some turbulence occurring. But what I like to call this turbulence is preferential turbulence. Then the reason why I call it preferential turbulence is because this picture, as you can see, represents velocity as the material flows across the bend. On the inside of your pipeline, you have a higher velocity, and on the outside, you have a slower velocity. Now imagine for a second that you are a particle. Your larger, heavier particles will short-circuit your bend and flow through the inside and afterwards report to the top of your process line. If you're a finer, lighter particle, you will be swept up by the water, move around the outside of the bend, and afterwards preferentially report to the bottom of your process line. So in sampling in this general area will give you biased results. So we've learned a rule or two with vertical line sampling. If we do, it is usually for process control purposes. It is on a pumped line, it has vertical upwards flow, and we need to install our sampler usually 2 to 3 pipeline diameters after a bend, a split, or a connection. And that will help with this preferential turbulence. But if you still only have a stationary cutter, or a cutter that only protrudes partway into your stream, what are you actually sampling? You're not giving each and every particle an equal opportunity to be sampled, and your flow will have an always changing bias. So can we do this a little bit better, maybe? It doesn't matter whether it's horizontal or vertical line sampling. If you have a cutter that crosses your whole stream, top to bottom, left to right, you will give each and every particle an equal opportunity to be sampled. Now, all that's left is frequency. We need to sample frequently enough, and that would be a metallurgical accounting sampling without any bias. Now, a lot of times when you have process control samplers, they are used for online analysis. But what are some of the keywords we look at when we try to buy an online analyzer? Accuracy, precision, repeatability, reproducibility. The second part of sampling theory states that we need to minimize and eliminate sampling errors from sample collection to sample preparation to sample analysis. Those 4 key words of accuracy, precision, repeatability, and reproducibility is not just for your analyzer. They need to be applied in your sample taking and your sample preparation systems as well. And that is where the RAMA system comes in. Now, what is the RAMA system really? It consists of an intermediate mechanically agitated hopper, a secondary time-resin sampler, and a sump and pump. The innovation does not lie in the development of new equipment, but how we are innovatively integrating proven sampling equipment to suit our needs. Now, there is one very key word that I listed there, secondary time-resin sampler, indicating that somewhere in your plant, you already have a primary metallurgical accounting sampler, be it a primary slurry sampler, a primary launder sampler, or a primary time-resin sampler. But where does the RAMA system fit in? It's not a primary sampler, it's not an analyzer, it is a sample preparation system that sits between your primary samplers and the analyzer. And what does it do? It collects a composite sample, it takes secondary subcuts for metallurgical accounting purposes, and it feeds your analyzer. When we look specifically at feeding the analyzer, standard continuous samplers open their process line only when it is due for analysis. And then suddenly you send this whole bunch of material past your analyzer only a single time, hoping that this analyzer can see each and every particle in that process stream in the few seconds or minutes that it has for the analysis. If we specifically look at feeding the analyzer, the RAMA system collects a composite sample. The composite sample is taken from your primary metallurgical accounting unit, and this sampler will take a few subcuts every 1 or 2 minutes, depending on your analysis period. These multiple subcuts are then taken to your intermediate mechanically agitated hopper. The mechanically agitated hopper ensures that the material stays well mixed while all the multiple subcuts are collected. Then, when this process line is almost required for analysis, the hopper opens up its valve and feeds your secondary resin sampler. The resin sampler then takes multiple subcuts that is used for metallurgical accounting purposes, and the rejects of the resin is fed to your sump and pump system. The results of this metallurgical accounting sampler can also be used for calibrating your online analyzer. And then finally, what we need this unit for is the sump and pump to feed your analyzer. So the sample material from the RAMA system does not pass your analyzer just once. We include a return line from the analyzer back to our sump and pump that allows the material to recirculate past the analyzer a minimum of 3 times, allowing each and every particle to be seen. We have also included a recycle line that is used to ensure that the material is constantly well mixed. After the material is done with analysis, it is discharged through a discard line and can be pumped back to your process stream if so required. Then, after the sample has been analyzed, the process line is flushed with water to ensure that there is no cross-contamination between this sample and the next. Now, that was quite a lot of information, so let's just take it in for a second. You have just analyzed an accurate, reproducible, unbiased sample in real time. That is quite a feat. But you might say, okay, but we don't just analyze one line. The RAMA system is customized. We can have multiple process lines included. Each line has its own separate process stream to keep them from being mixed and preventing cross-contamination. Each process stream's hopper also includes level switches to accommodate process flow changes. And on top of that, you have a batch sample collected by a secondary resin sampler that's used for metallurgical accounting and for analyzer calibration. Finally, the RAMA system is identified as a preparation system, so it needs to be fairly close to your analyzer. So what did we do? We containerized it. It limits the influence on your infrastructure and your civils required, and we have the sump and pump system that can be used to feed your analyzer, no matter where it is. This also makes the unit modular, easily expandable, as each containerized unit is equipped with 4 process lines. The unit comes complete with a PLC ready for plug and play, and the containers are pre-built and factory tested, making them easy to transport and install and significantly easing the commissioning process. Now, that sounds like innovation. Only a change in how we feed an analyzer with equipment we already are well familiar with has allowed our results to be accurate, on the mark, in real time, all the time. Thank you.